ఓకే. సో ఇది పెట్టలే కదా, మన ఫోటో ఏం పెట్టలేదు. మామూలు చూపిస్తాను. వద్దులేదు సార్, వద్దులేదు. Organic compound containing a OH functional group. The OH functional group is attached with the aliphatic group. That one is called as alcohol. The general formula of alcohol is ROH. This is a hydroxy group, and this is a aliphatic alkyl group. Suppose if the OH group is attached with directly bonded with aromatic benzene ring, then it is called as phenol. The general formula of phenol is PHOH. Here the OH group is directly attached with the phenyl ring. Let us take the classification of alcohols. Alcohols, let us take alcohols. Based on number of OH groups, alcohols can be classified into two types. One is monohydroxy and second one is polyhydroxy. And second one is polyhydroxy. First one is monohydroxy, and what is the second one? Second one is polyhydroxy. In monohydroxy we have methyl and primary. In polyhydroxy we have two or more than two OH groups. Okay, this is the classification of alcohols. Let us take what are the examples of monohydroxy compounds and polyhydroxy compounds. Let us take monohydroxy compounds. In monohydroxy compounds we have only one OH group. Let us take first one, and this is methyl alcohol, and this one is primary alcohol, and this one is secondary alcohol. This one is tertiary alcohol. Okay, how can you classify primary, secondary, tertiary, and methyl? In the case of methyl, the carbon is attached with 3 hydrogens, so it's not primary, secondary, or tertiary. In case of primary, the OH which is attached with the carbon is attached with only one carbon, so it's a primary carbon. So the OH nomenclature of alcohols, it's a systematic nomenclature. We know what is IUPAC, International Union of Pure and Applied Chemistry. Based on some rules in this system, we have to give naming to the alcohols. In common nomenclature, alcohol. So this is a common nomenclature. Suppose if you take a simple alcohol CH3OH. What is the alkyl group? Here the alkyl group is methyl, and simply you have to add. Okay, this is a common nomenclature of CH3OH, that is methyl alcohol. Let us take two carbons containing alcohol CH3, CH2, OH. Okay, in this case you have CH3, CH2. It is called as ethyl. The alkyl group is ethyl, so you have to add alcohol. And if you take three carbons containing alcohol, that is CH3, CH2, CH2, OH, of alcohols. So let us take three carbons containing. Let us take three carbons containing CH3, CH2, CH2OH. Here how many carbons are there? Three carbons are there. So the root word is prop. It's a alkane. So the primary suffix is a. And what is the secondary suffix? The main functional group is vol. Okay, in place of E you have to write down vol. You have to remove E. So it will be propanol. This is about common nomenclature and IUPAC nomenclature of alcohols. We know the Markovnikov rule. According to Markovnikov rule, if you take let us take H and more electronegative element. Let us take more electronegative element. Let us take OH. Suppose if you add H and OH. In case of electrophilic addition reaction, Markovnikov rule, the H adds at more number of hydrogens. Generally H adds at this position and OH adds at this position in case of electrophilic addition reaction. But if you take hydroboration, oxidation, the addition of H takes place here, less number of hydrogens, and the addition of OH takes place at more number of hydrogen. Okay, the rule is anti-Markovnikov rule. According to Markovnikov rule, more electronegative element should attach with the more substituted carbon of the alkane, and less electronegative should attach with the less substituted carbon of double bond. But here finally if you take the product, hydrogen is attached with more substituted carbon, OH is attached with the less substituted carbon, so it follows anti-Markovnikov rule. First there is a addition of BH3. It's a syn addition. There is addition of hydrogen at more substituted carbon, BH2 at less substituted carbon. Generally we take tetrahydrofuran as a solvent. Generally we take ethers as a solvent in the case of hydroboration reaction. When you treat with H2O2, it's an oxidation of BH2. The BH2 will be replaced by the OH group. So finally there is a hydroboration, addition of BH3, and there is a oxidation. After oxidation you will get alcohol. So from alkenes you can easily prepare alcohols by using hydroboration method. Okay, let us take this alkene, simple alkene, and there is a addition of BH3. So here there is a breaking of this bond. This double bond will be dissociated. Here there is a addition of H, and here there is a addition of BH2. It's a syn addition. And after treating with hydrogen peroxide in OH minus, okay, there is a replacement of BH2 with OH. So finally you will get alcohol. Okay, this is the mechanism of hydroboration oxidation reaction. First, there is a addition of BH3. This is the addition of BH3. This is the transition state you will get. Let us take this is the hydrogen, and this is the H. Here these electrons comes like this, and these electrons comes like this. So here H. Here at the same time there is a formation of bond between carbon and boron, and there is a dissociation of bond between boron and hydrogen, and also dissociation of bond between carbon and carbon. That's why in this transition state you can find some partial bonds. This is the intermediate you will get. On carbon which is attached with hydrogen gets partial positive charge, and boron gets a partial negative charge. This is a transition state you will get. And when you treat with this transition state is decomposed, finally this hydrogen is attached with this carbon and BH2 is attached with this carbon. When you treat with hydrogen peroxide in OH minus, in place of BH2 you will get OH. Okay, this is the mechanism of hydroboration oxidation of alkenes. And the second method, this one is very important method. From Grignard reagent you can prepare all types of alcohols. You can prepare primary alcohol. This one is very important method for the preparation of all types of alcohols, and also you can prepare secondary alcohol, and also you can prepare tertiary alcohols. Okay, this one is very important method for the preparation of alcohols. Suppose if you take formaldehyde, when you take formaldehyde you will get primary alcohol in case of Grignard reagent. Aldehydes other than formaldehyde you will get secondary alcohol. Ketones you will get tertiary alcohols. Esters, when you treat esters with excess amount of Grignard reagent, you have to take excess amount of Grignard reagent, you will get tertiary alcohols. Okay, let us take formaldehyde. This is our formaldehyde, very simple aldehyde. When you treat with alkyl magnesium halide, this is a Grignard reagent. We know that Grignard reagent it's an organometallic compound, and here carbon is more electronegative than metal, Mg, so carbon gets partial negative charge, magnesium gets partial positive charge. This one acts as a nucleophile, so it attacks on electrophilic center, carbon, and electrons moves like this. So here you will get C, O, and H. This is the R group will attach with carbon of carbonyl group, and MgX, this one will become O minus, and MgX plus will attach with the O minus. Upon acidic hydrolysis, when you treat with H plus, you will get alcohol, corresponding alcohol. This is the alcohol you will get. Since the carbon is attached with only one alkyl group, it's a primary alcohol. So from formaldehyde you are getting primary alcohol. Similarly, suppose if you take other than formaldehyde, let us take other than formaldehyde, let us take R dash C double bond OH. Okay, this is the aldehyde other than formaldehyde. When you treat with alkyl magnesium halide, RMGX, again here it's a nucleophile, so this nucleophile attacks on positively charged carbon of carbonyl group, and you will get R's, these electrons moves like this, and you will get O minus MgX plus, and this one is hydrogen, and this one is R. Upon acidic hydrolysis, same mechanism, H3O plus, when you treat with acid, R dash, and here there is a breaking of bond, So here there is attachment of H, and here there is attachment of OH. So you will get here OH, and this is hydrogen, and this is R. Here there is a removal of MgXOH. It's a secondary alcohol. It's a secondary alcohol. Suppose if you take a ketone, RC double bond, let us take R1 and R2, two different alkyl groups. Let us take. When you treat with the RMGX, again there is a addition, nucleophilic addition. All these are first step, there is a nucleophilic addition. In all these cases there is a nucleophilic addition. The nucleophile R attacks on electrophilic center. Here O minus MgX you will get, and this one is R2 and R. Upon acidic hydrolysis, same conditions, you will get R1 COH, R2 and R. Okay, it's a tertiary alcohol. You will get tertiary alcohol. So from formaldehyde you are getting primary, other than formaldehyde, aldehyde other than formaldehyde you are getting secondary, and ketone you are getting the tertiary. And from ester also you can prepare tertiary alcohols. How can you prepare from ester? This is ester, RC double bond O R. Let us take R1 and R2, this one. When you treat with RMGX, first there is a addition, R1 and O minus, OR2, and here there is a R, and these electrons comes like this, and there is a removal of OR2. You will get R1 C double bond R. Same mechanism. If you take ketone, when you treat with excess amount of, and again if you treat with RMGXO, finally you will get, upon acidic hydrolysis, same mechanism, you will get R1 COH R and R. Here also you will get tertiary alcohol. What is the other method? You can prepare alcohols from carbonyl compounds by the reduction. When you reduce aldehydes or ketones and also carboxylic acids, you will get alcohols. Suppose if you take formaldehyde, HC double bond OH, when you treat with lithium aluminum hydride and sodium borohydride, these are reducing agents, hydride donors, and here there is a formation of CH3OH, methyl alcohol. Suppose if you take aldehyde other than formaldehyde, RC double bond OH, this C double bond O will become CHOH. Here there is a addition of H, and here also there is a addition of H, and here you will get primary alcohol. And if you take a keto, RC double bond O R dash, when you treat with lithium aluminum hydride or sodium borohydride upon acidic hydrolysis, you will get secondary alcohols. Here this hydrogen comes from hydride donor, that is NaBH4 or LaLH4. This hydrogen comes from acid H+. Here also one of the hydrogen comes from hydride donor, that is LaLH4 or NaBH4. This hydrogen comes from acid. When you treat RCOOH, okay, in this case NaBH4 is a weak reducing agent when compared with lithium aluminum hydride. The carboxylic acids cannot be converted into alcohols by using NaBH4, but you can reduce carboxylic acids, this is RCOOH carboxylic acids, into alcohols. Okay, these are the preparation methods of alcohols. Let us take a preparation of phenols. We know that the the molecular formula of the structure of phenol is one of the hydrogen of benzene is replaced by OH, and this is a formula C6H5OH, and also it is written as PHOH, and the derivatives of phenols are represented as AROH. This is a structure. Then how can you prepare phenols? Simply nucleophilic substitution reactions. By nucleophilic substitution reactions you can prepare phenols. Okay, benzene sulfonic acid, if you take NaOH, when you treat with the NaOH with the benzene sulfonic acid, here you have to heat the solution, then you will get, in place of SO3H, there is a substitution of OH. And also if you take chlorobenzene, here also you have to heat, vigorously you have to heat the solution. When you treat with sodium hydroxide, in place of chlorine there is a substitution of OH. It's a nucleophilic substitution reaction of aromatic compounds. So here there is a, in place of Cl you will get OH. And also you can prepare phenol from cumene. This is a cumene. You can prepare phenol from cumene by oxidation with the atmospheric oxygen. In presence of acidic condition you will get alcohol. And also from diazonium salts, in acidic condition at 100 degrees centigrade, there is a nucleophilic substitution reaction. There is a substitution of OH in place of azo, N2 plus group. So these are the four methods by which you can prepare phenols. Okay, let us take cumene. From cumene, how can you prepare phenol? Let's take the mechanism of preparation of phenol from cumene. Okay, this is a mechanism which is mentioned in our syllabus. Let us discuss mechanism of cumene to phenol. Okay, this is the cumene. What is the nature of this carbon? The carbon is attached with methyl group and methyl groups, two methyl groups, and there is a phenyl group. It's a tertiary carbon. Okay, when you treat with atmospheric oxygen, there is a generation of free radical. Okay, this is a structure of O double bond O. Okay, this oxygen abstract product. There is a homolytic dissociation between CH bond. There is a homolytic dissociation between CH bond, and this carbon gets electron, single electron. This hydrogen gets single electron, and there is a attachment of this hydrogen with oxygen. So you will get a tertiary benzylic free radical. This is the first step. In second step, again this oxygen molecule which is present in the atmosphere will combine with the free radical, and here there is a formation of free, and this free radical in the next step, hydrogen. This hydrogen, here you have one hydrogen, two methyl groups and one phenyl group. This peroxide free radical, decomposition of cumene hydroperoxide. This is a cumene hydroperoxide which is formed in the propagation step. Upon acidic hydrolysis, there is a migration of this phenyl group to the oxygen, and you will get this intermediate. Here this phenyl group migrates towards, first there is a attachment of H plus, so this one will become OH2 plus, and OH2 plus is a better leaving group. Actually, if OH is present, this ring cannot attack. Here it can attack, but since OH is a poor leaving group, there is no leaving of OH when this phenyl ring attacks on the oxygen. But when you treat with H plus, the OH become H2O plus. H2O plus, we know that H2O plus is a best leaving group. So when this phenyl ring attacks on the oxygen, the H2O group, H2O plus group leaves from the oxygen as H2O. Again, you are getting this carbocation, and this carbocation will be reacted with water molecule which is generated in the previous step, and he will get this one. And here there is a transfer of proton from this oxygen to this oxygen, so you will get OH plus, and here OH plus, PHOH plus is a better leaving group, so these electrons comes like this, and this one comes as a phenol. Okay, this is a decomposition of cumene into cumene hydroperoxide into phenol, and finally you are getting byproduct acetone. In the case of cumene, in the case of synthesis of phenol from cumene, you are getting a byproduct. It's very useful. It is very useful. It is used as a solvent in the industry.